All right, now we're going to take a look at some computer software output for statistics. Here's our first look at it. All right, I got two examples of computer output for some data from an example in SEC football. Okay, I'm not sure what the other variable is. There's two variables about football. One of them is points per game. I don't know what the other one is, or remember anyway. One of them is called Minitab. It's been around since I was in college. That's a long time ago. And the other one's called Jump. That one's a bit newer. We actually have it on our computer in the network, but of course you can't put it on your Chromebooks, which is just genius. Go Knights! So anyway, we'll use both to find the least squares regression line and interpret slope, y-intercept, and s. Okay, this is what Minitab's output looks like when you put data in it and you ask it to run it. Okay, your world right now for chapter 3 is just this part right here. This is called the standard error of the coefficient, and we do not use it. We will use t, and we will use p way down the road in the second semester, and r squared adjusted is something we're not interested either. These things over here. Now, look, the title of this column is coefficients, and we're talking about y hat equals a plus bx. Aren't these the coefficients, right? Number in front of x, and a constant technically is a coefficient. It just doesn't have an x. Or better said, it's x to the 0. Okay, so the first one that we see is for the constant. Well, which of these two is a constant, right? The second one, points per game, has to do with the variable. So x is clearly the variable points per game in SEC football. Unfortunately, I don't have or remember what the y variable is, so it's something about football. Anyway, it's always going to be the case that A is the top row because that's the constant in that equation, and B will be the bottom row. And so if those are coefficients, what this output is telling me is this is A and this is B. Negative 3.751 is A. 0.43721 is B. Now S down here in the bottom left, that is the standard deviation of the residuals. And then r squared here, well, if r squared is equal to 0.876, couldn't we just find that r is equal to plus or minus the square root of 0.876? Now, I can figure out if r is plus or minus because of the direction the line is going. Okay, so let me drop down here, and I'll go over the Jump software as well, but I now know that a is negative 3.751. Did I do that wrong? No, I got that right. A is negative 3.751. And B is 0.43721. Okay, so the least squares regression line is y hat is equal to a plus bx. That goes negative 3.751 plus 0.43721x. And of course, since they told me, I'm just going to put above here that that is the variable points per game. This is the variable, put a question mark, something about football. Okay, r is going to be plus or minus the square root of 0.876. Now, take a look at your slope. Is the slope positive or is the slope negative? Since the slope is positive, that means it goes like this. If it's a positive slope and the scatter plot goes like this, doesn't r have to be a positive square root of 0.876? So I'm going to go down here, I'm going to put positive square root of 0.876, and then I'm going to find my calculator around here somewhere. There it is. That's upside down. There you go. You guys got it. Okay, so square root of 0.8, nope, that's wrong. Misspelled it. I get 0.936. This is 0.936. That's a pretty strong correlation. And the S is just right here in the bottom left for Minitab. It's 1.23531. Okay, got all the data I need from the calculator. The last thing for us today is to interpret our numbers. I suppose, wait, sorry, I said last thing, but I suppose I should go over this Jump software because you will see this one as well. Here, once again at the top, there's r squared, so that's what r squared is. I actually have an interpretation for r squared for you in the next notes. R squared adjusted, don't care. Root mean square error. Wow, that sounds like it's something I don't need, doesn't it? Root mean square error. Root mean square error. Hang on. Root square error. That's starting to look familiar. Root mean means to add up a whole bunch and divide by something. Isn't that the formula for S? The root of the mean of the square of the errors. Boy, I like the other version a lot better. Oh, look, it's the same number, isn't it? Well, look at that. So S in jump is kind of hidden behind these words that describe what's going on in that formula I gave you the other day. The mean of the response variable, I don't know that I really need to know the mean of y's, but we found out that it's part of the center of gravity point. How many observations are it? That's just their n equals 12. We had 12 data values. But the real thing we're looking for is down here at the bottom. It's right here again. I don't need this, I don't need this, I don't need this. Now look, this part looks the exact same as the Minitab stuff, doesn't it? And so the intercept is A, that's negative 3.75. And the points per game, that's the slope, it's 0.43721. Okay, let's interpret some things and we get out of here for the day. Slope as points per game, I'll even put it in quotes, as points per game. The interpretation of slope is as x increases by 1, y increases by slope, right? As points per game increase by 1, I'm going to put in parentheses. We have a question mark for this because we don't know what it is, so I'm going to put something about football. Something about football increases by 0.43721. I don't have units to go with that because I don't know what I'm talking about. Okay, the y-intercept. Well, I don't even know if this is helpful. I'm going to suggest that it's probably not. But when points per game equals 0, which means the team got shut out, right? Something about football is predicted to be, we should keep the word predicted in there. It's predicted to be negative 3.751. I'm guessing that's another nonsense kind of interpretation, but hey, I did it. And then S, the standard deviation, the root mean square error, the S from up there, the points. Let's go with a fancy word instead of are off. We're going to say they differ, very fancy, from the least squares regression line of, remember this phrase from the other day, y on x. So I'm going to write something about football, and I'm just going to abbreviate and write football on points per game, y on x. Okay, the points differ from the least squares regression line by an average of 1.23531. Hey, there you go. You learned how to look at some software output and where it's always going to be, so you can pick some numbers out of there and make your least squares regression line. You can make predictions. You can take the r squared and turn it into r. You just got to watch your slope. Is your slope positive or negative? That tells you whether r is positive or negative. And we find out that it's a pretty strong relationship. We got an A and B. We find out that the points are off from the line by an average of 1.23. That means they're pretty close to that line, which, you know, this is another way of saying that, right? 0.936. So there you go. Not too much today, and let's try some homework on page 207. I've got you guys. Okay, so here's my old notes. There's no way that this is all of the homework. There's just no. Do you see what's going on here? The former Larson, not only, if you look at this, I had these backwards. Okay, so let's just, we just put an angry face on there. There's an angry face. But look, it looks like I don't think I should just give you one homework problem for the weekend, do you? That seems a little light. Good enough. Enjoy your weekend.